Hi, I'm Sheila Voss, Vice President of Communications for the Good Food Institute. On behalf of my GFI colleagues in the US and around the world, welcome to Setting the Stage. This is a special presentation that we all wanted to make available prior to convening this year's Good Food Conference. Think of this as your primer and your preview for GFC 2021. It features a set of expert-led presentations that together provide a solid foundational view of the alt protein landscape today. But first, a few insights. This year's conference theme is charting the global roadmap for alternative proteins. It's a dual nod to the importance of grounding ourselves in today while equipping us all for a far better food system of tomorrow. We will convene virtually from September 22nd through 24th, using the Hopin platform as our online gathering space this year. Convening in this way enables us to connect across geographies and time zones, and makes it far easier to bring a diversity of voices together to tackle important topics, share knowledge and timely insights, and help each other chart the road ahead. We aim to bring together practitioners from across the field, scientists and researchers, students, faculty, and other academic leaders, startups, entrepreneurs and investors, retailers and food companies of all sizes, policymakers, government agency representatives, funders, philanthropists, and nonprofit allies working alongside all of us at the intersection of climate, global health, biodiversity, and sustainable agriculture and food systems. Now more than ever, we need more bright minds from a diversity of disciplines, a diversity of backgrounds, a diversity of life experiences to see themselves in this important work, to support each other and clear the path together and fast. To be sure, this year's conference is most definitely not Alt Proteins 101. It's more like 301 and 401, with each session diving deep into some of the most critical components, from science and technology to industry innovations, strategic and timely investments that are needed now, and policies that enable, incentivize, ease, and accelerate the transition ahead. This transition, this shift, if it is to happen at the scale and pace needed, will require even more of us to see ourselves in the work. This is a global transition, a global transition. And the transition to a far more efficient, land-saving, water-saving, ocean-saving, nature-forward way of making the foods we all love. And it will not happen by accident. It will happen, however, with intent, with relentless focus, with good science, with well-funded science, with corporate leadership and vision and action, with policies that prioritize the public good, with cross-sector collaboration, with persistence, with partnerships. It's these concepts and these conditions that are at the heart of this year's Good Food Conference. But don't just take my word for it. I have invited a few close colleagues to chime in from wherever they're at in the world to share a bit more about our rationale and thought process that went into this year's sessions, and to also underscore from their own perspective just exactly what's at stake.
I'm Liz Specht, GFI's Vice President of Science and Technology, and I'm speaking to you from a smoky Washington state where the haze in the sky serves as a constant reminder of the urgency of transitioning toward alternative proteins. This urgency is the basis for our main theme when picking the technical sessions for this year's conference, and that is scale. We have 4 deep dive technical sessions, and all of them build on this element of scale. One is on advances in cell culture media for cultivated meat, which is absolutely critical for cost reduction and mainstream adoption. The second is on production equipment innovation to allow us to move toward manufacturing plant-based meat at the level of hundreds of millions of tons each year. Third, we have a session on ingredient processing for alternative proteins, since the whole agricultural supply chain needs to gear up for this transformation from field to fork. Finally, we have a technical session on precision fermentation, which has emerged as a formidable tool for improving sensory appeal and thus supercharging the increase in consumer demand that's driving this need for scale. Of course, we all know these technological innovations don't happen in a vacuum, and that leads us to our second main theme, which is building robust innovation ecosystems. We have a session on collaborative models for integrating stakeholders across academia, government, and industry to create and commercialize technological solutions. We also have a session on building a diverse talent pipeline for this industry to service the need for a substantial workforce. And last but not least, I'd like to highlight two sessions that will elevate voices from two of our most impactful stakeholder communities: our grant recipients, who are at the forefront of innovation in this field, and our Alternative Protein Project student groups, who build engaging collaborative hubs on campuses across the globe. I'm personally blown away by the roster of thought leaders we've assembled to share their insights at these sessions, and I hope to see you there.
Hello, Good Food community. I'm Caroline Bushnell, Vice President of Corporate Engagement with the Good Food Institute. I'm speaking to you today from Boulder, Colorado, which, along with much of the Western United States and places across the world, is increasingly experiencing the effects of climate change. As the latest IPCC report has made crystal clear, business as usual is no longer an option. We need transformational change. And agriculture, specifically how we produce proteins, must be a part of that. Alternative protein technology is a critical tool that we can deploy globally to reduce emissions and build a more sustainable, secure, and just protein supply. This year's conference couldn't be more timely, and it's full of sessions for audiences across the field. I'll give you a quick preview of the sessions for those in the private sector. First, we'll set the vision for where we're headed over the next few decades, a future where alternative proteins are no longer alternative. We'll dig into consumer insights with major research and data firms, as well as leading industry companies. And we'll discuss some of the key industry bottlenecks and analyze solutions to build the roadmap to 2050. There is a constellation of voices to hear from in the startup and investor space. We'll bring together both investors and startups for roundtables. We'll have some fun with a crowd favorite, pitch slams. Over 100 alternative protein startups applied to give you their pitch, and you'll hear from the 12 finalists. And bringing it back to impact, we'll connect the dots between corporate social responsibility, ESG investing, and alternative proteins. We'll also discuss solutions for vibrant ocean ecosystems. I'm thrilled for the opportunity to explore these topics and learn from leaders across the entire field. It's sure to be an incredible 3 days, and I hope to see you there.
Hello, Good Food Conference attendees. I'm Jessica Almy, the Good Food Institute's Vice President of Policy. Normally I'd be in Washington, D.C., but I'm joining you today from upstate New York during the August recess. This year's Good Food Conference is incredibly exciting. We have 4 times the policy content as we had in 2019. The sessions run the gamut from an exploration of how alternative proteins can help governments meet their biodiversity, climate, and land use goals, to a glimpse at how regulatory frameworks can be leveraged to bring cultivated meat to dinner plates from Singapore to, we hope soon, the United States. And of course, we'll be treating you to a perennial favorite, a panel on label censorship, the practice of banning terms like burger on veggie burger labels and sausage on boxes of plant-based sausages. An absurd policy which makes about as much sense as forcing the makers of the candy Swedish Fish to avoid the word fish, or banning Girl Scout cookie boxes when they don't have Girl Scouts inside. We have some incredible policy experts joining us this year. I'm deeply grateful to them for spending their time with us, and I cannot wait to see you there.
Hello, friends. I'm Bruce Friedrich, founder and CEO of the Good Food Institute. 5 years ago right now, the Impossible Burger was available in a total of 1 restaurant in the entire world, and the Beyond Burger was available in 11 Whole Foods grocery stores, 9 in Denver, 2 in Washington, D.C. 5 years ago right now, there were just a few cultivated meat companies that had raised any money at all. Total fundraising was under $5 million, and no mainstream VC or major food company had invested a dime in cultivated meat. 5 years ago right now, government policy was even further behind, and so too government funding. Nothing was happening at the regulatory bodies, and no government had yet recognized the importance of plant-based and cultivated meat to food security or climate goals. 5 years ago right now, no scientist had plotted the technological readiness of either of these technologies, and total open access funding to both of them was well shy of $3 million in all of human history. What a difference 5 short years can make. Today, the private sector is all in on making meat from plants and cultivating it from cells. Top agricultural universities around the world have launched alt protein programs, and policymakers in India, Israel, Brazil, Singapore, China, Japan, the US, Canada, and countries throughout Europe have recognized that these food technologies will have to succeed if we want to meet our climate and biodiversity goals. Literally none of this was happening just 5 short years ago. We've come a long way, but we still have a long way to go. Alternative meats will only reach their potential when they satisfy all consumers for a lower price. At GFI, we are convinced it's possible, but it's going to require that scientists, governments, NGOs, and industry work together and double down on what we've accomplished so far. The sessions of GFC 2021 are focused on bringing together the most important people from across the world, from industry, from science, and from governments. GFC 2021 is the launching event for the next 5 years. I am very excited to see you there. Thanks.
Okay, so hopefully that got you revved up. I know I am. Before I turn it over to the main event, a crew of colleagues who are on deck to share the state of alt protein science and innovation today, just 3 quick hop-in tips to make the most of your experience. Ready? 1, register. If you haven't already registered, do so today. For an early bird discount, register by August 30th. We do not want the registration fee to be an obstacle for anyone. So we're also offering a student/nonprofit attendee fee, as well as a scholarship option. The final deadline to register is September 15th, and the full conference again is September 22nd through 24th on the Hopin platform. 2, upon registering, fill out your profile on the Hopin platform. Be sure to enter in your email address, LinkedIn page, or any other contact information you'd like, which will help you network with others and share contact information if you so choose. To orient you to the Hopin event experience, we recommend you check out Hopin's attendee experience demo, the link for which is in this video description on YouTube. It's a friendly 10-minute orientation that helps you know exactly what to look for, what to expect, and how to navigate around the Hopin site before and during the event. Highly recommend, very much worth the time. 3, familiarize yourself with our session lineup. On the registration page, you'll find the conference schedule. We recommend taking some time in advance of the event to check out the 3 days worth of sessions, as there are a few concurrent ones throughout. As we get closer to the event, we'll be adding details about speakers, sponsors, expo hall exhibitors, and other updates to Hopin. So it's a great place to stay in the loop. Okay, that's it for now. Without further ado, I cede the virtual floor to my brilliant GFI colleagues, Pri, Claire, Ryan, Sharon, and Marika, who collectively are about to give you the most solid view of the alt protein landscape available today. On behalf of the entire Good Food Institute team, we look forward to seeing all of you at the Good Food Conference 2021.
Hello and welcome. My name is Priya Panescu, and I am a senior scientist at the Good Food Institute, focused on plant-based ingredients. I am excited to kick off the 2021 Good Food Conference by setting the stage with a plant-based 101 introduction. This talk will focus on the science and recent advances of plant-based meat, egg, and dairy products. One of the most notable differences in animal-derived products compared to their plant-based counterparts are the source proteins. Plant proteins are typically globular and spherical in shape, while animal proteins have more fibrous structures. To replicate the same texture and experience as animal-based products, plant protein raw material sources, processing, and texturization are continually being advanced. As a result, opportunities for plant-based meat, egg, and dairy products exist across the entire value chain. For example, crops have historically not been optimized for their protein content or the functionality required by many plant-based products. The plant-based ingredient industry has a need for crop development through selecting new crop sources, as well as breeding or engineering plants for optimal protein content and functionality. Similarly, ingredient processing has traditionally been focused on oil and carbohydrate extraction, but efforts towards excellent plant protein enrichment and functionalization are necessary. Lastly, end product formulation and manufacturing can further enhance plant protein products by adding other plant-based raw ingredients that improve ingredient mixture properties, as well as by texturizing proteins for alternative meat products with great structure and mouthfeel. The end result of these processes will help plant proteins exhibit lower levels of metabolites and enzymes that negatively impact taste, as well as provide higher protein content and functionality, like improved solubility, water binding capacity, fat binding capacity, and texture, all of which contribute to the desirable sensory attributes in plant-based end products. Lastly, open access databases across all three of these phases are necessary to further propel innovative plant-based products. I will talk about the science and advances for each of these stages. First, I'll zero in on opportunities in the crop development phase. This table displays top plant-based meat brands in retail by the protein that they use in their products. We can see that many brands use soy or wheat in their products, while several also use peat. It's important to note that a factor that leads to the use of these plant proteins is that soy, peat, and wheat have been widely used as commodity pulses and grains. But the protein from these plants has mostly been left over by production of oils or animal feed. This isn't to say that soy, peat, and wheat are poor choices, but rather they're used because they're available. But there is potential to increase product functionality and performance from other plant protein sources if these can be produced at scale. This chart demonstrates some properties of soy, pea, and wheat proteins, including protein concentration in the crops, their digestibility score, PD-Cas is utilized here, allergen risk, commercial stage, flavor, etc. Because these proteins have been available through other processes, they have high commercial stage and functionality scores, as well as low costs. However, there are many considerations that should be taken into account when exploring plant protein sources. Novel sources with lower allergen risk, better flavor, as well as better consumer perception, for instance, are continually being developed and should be developed. This table displays examples of novel proteins that have the potential for use in plant-based product formulations. 2020 brought major developments from companies working to commercialize other novel crops relevant to alternative proteins. Quinoa market leader, Northern Quinoa Production Corporation, formed a partnership with Ingredion to commercialize quinoa flours and concentrates. Puris, a Minnesota-based breeder and processor of non-GMO crops, launched a lupin-based flour. And Plantable Foods articulated plans to release its lemna, also known as duckweed, protein commercially in 2021. The tables displayed from the previous two slides are from GFI's Plant Protein Primer resource. I strongly encourage you to refer to GFI's Plant Protein Primer for any additional information on novel proteins and application of these proteins. In addition to novel crop sources, crop development through breeding strategies that focus on enhancing protein composition and functionality are necessary. Here are just a few examples of companies tackling breeding research for plant proteins. Equinom uses a non-GMO seed breeding method to create golden trait seeds that are optimized for use in alternative protein products. Benson Hill, a seed breeding company using both traditional and GMO breeding methods, announced plans to release its ultra-high protein soybean varieties in the 2021 crop year. If successful, these varieties will be the first commercially available soybeans that could effectively replace soy protein concentrate made through traditional dry and wet fractionation steps. Yield 10 and Rothamsted Research announced a partnership aimed at commercializing a CRISPR-edited camelina plant capable of synthesizing the highly unsaturated omega-3 fatty acids, EPA and DHA. An abundant source of low-cost, animal-free omega-3 fatty acids will be required for alternative proteins to mimic the nutrient profile found in fatty fish such as salmon and tuna. Beyond crop development, there are also many interesting opportunities and advances within the ingredient optimization phase, where plant proteins are processed into their formulation components. Proteins are often extracted to improve their properties for a set of applications. This usually focuses on the removal of macromolecular components, including oil, starch, and fiber. Often this process also removes protein components as well. And the type of process will determine which components are retained and which are removed. The process can also intentionally or unintentionally alter the functional and nutrition properties of proteins in a variety of ways, including denaturation, hydrolysis, chemical modification, and cross-linking. One of the highest priorities for alternative protein scaling is identifying new chemical, mechanical, and biological processing methods that can offer high output quality and functionality benefits while also being inexpensive, more efficient, and compatible with diverse crop inputs, as well as less scale dependent than current processes. Companies that are currently working on advances like these include Botanico, which is commercializing novel separation and purification techniques that disassemble oil seeds in aqueous processes, isolating the components of the seeds without destroying the structure, purity, or functionality of its proteins. The result maintains a low carbon footprint and enables the recovery of high quality oleosomes and proteins. Key Leaf is exploring new ways of fractionation to find plant-based proteins that can replace traditional animal-based proteins across food, cosmetics, and bioproduct applications. Finally, Puris, in addition to developing a lupin flower, is breeding and processing other crops such as yellow pea, soy, lentil, and corn. Their goal is to extract 100% of the peas, starches, sugars, fibers, and more from the crops, thus lowering waste, their environmental impact, and production costs. In addition to crop development and ingredient optimization, another area of focus for technological advancement is end product formulation and manufacturing. Existing end product technology mainly involves mixing, molding, forming, and extrusion. The same key equipment manufacturers provide twin screw extruders for both high moisture extrusion and low moisture extrusion. We've seen innovation in a few key categories as outlined here. Mechanical innovations such as 3D printing and shear cell technology, as well as biological innovation, including biofabrication and fermentation. For the purpose of this introduction, we'll focus on 3D printing and shear cell technology. 3D printing can improve manufacturing precision and flexibility, enabling the fabrication of highly sophisticated products that mimic whole muscle meat cuts. Examples of companies exploring 3D printing in 2020 include Redefine Meat uses a 3D printing process with 3 separate tubes to manufacture its next generation plant-based beef, pork, and lamb steak to replicate the fat, blood, and muscle components typically present in conventional whole cut meats. Nova Meat created more sophisticated versions of their 3D printed products, including beef, pork steak, and improved chicken and fish fillet products. Another technology focused on solving the texture challenge is shear cell. Shear cell technology creates fibrous texture by applying shear force to plant proteins between two cylindrical rotating plates. The commercialization of shear cell technology has been spearheaded by the Plant Meat Matters Consortium at Wageningen University and Research in the Netherlands, with collaboration from food industry partners, Avril, Ingredion, Givaudan, The Vegetarian Butcher, and Unilever, among others. The only company currently deploying commercial shear cell technology is Rival Foods, which recently entered into a partnership with Live Kindly Collective to create plant-based chicken through shear cell technology. Lastly, I will briefly touch upon the importance of open access databases to support all of the three phases across the plant protein value chain. Data collection and analysis across all phases of the plant-based meat development process are incredibly important to help identify the most pressing issues and opportunities for optimization. Databases which contain crop growing conditions, phenotypes, and genotypes can help guide breeding efforts. Data that connects protein sequence and structure to its functionality would further help plant-based products reach taste parity as well as texture parity with animal-based products. Creating open access databases with advanced protein information could reduce duplicative efforts between companies, as well as lead to more innovative and diverse products. Thank you so much for listening to the Setting the Stage Plant-Based 101 video. Have an excellent time at the Good Food Conference.
Hi everyone, welcome to the Good Food Conference. My name is Claire Baumkamp. I'm a senior scientist at the Good Food Institute. In this video, I'll be giving a little bit of background on the science of cultivated meat and also some context as to where we are in the process of scaling up this industry. So let's start with a quick definition. So what is cultivated meat? Cultivated meat is genuine animal meat that can replicate the sensory and nutritional profile of conventionally produced meat because it's comprised of the same cell types arranged in the same three-dimensional structure as animal muscle tissue. So you may have also heard this referred to as cell-based meat or cultured meat. This is basically the idea of producing real animal meat without the animal using tissue culture techniques. So this is a very general schematic of what the production process might look like. So we start with a small sample of cells obtained from an animal, and this can be, as small as a tiny tissue biopsy the size of maybe a sesame seed or a sunflower seed. You really just need a few cells to get the process going. And so once you have your cells, they go into a proliferation phase in which we take advantage of the fact that cells grow exponentially to go from that small number of starting cells to actually a large number of cells that will form the final meat product. So after that, we don't really want just a cell slurry, we want an actual meat product. And so for that reason, we're going to have the second stage of tissue maturation in which the cells are induced to differentiate into particular cell types, so primarily muscle cells, but also fat cells, fibroblasts, and maybe other cell types, depending on the product you're going for. And they're also going to form a three-dimensional geometry that will recapitulate the structure that you would find in conventionally produced meat. And the goal here is to really reproduce the physical appearance, the texture, everything you would get from the experience of eating genuine meat from that tissue. And so we can divide this process into four broad areas. So cell line development, development of the culture media in which the cells will grow, development of scaffolding, which is the support structure the cells will grow on, and then design of the bioreactors and the overall bioprocess through which you'll produce your product. So I'll go into each of those four in a little bit more detail in the next few slides. And on the cell culture media side, an interesting note is just that there's actually a huge potential for cost reduction here. So if you're looking at sort of the biggest white spaces to bring down the cost of cell culture media relative to what's used in sort of lab scale bench research, there's really a huge potential to bring down those costs and therefore the costs of cultivated meat. So a little bit more detail on cell line development. I'll just start by defining some terms here. So when we talk about the different cell types used in cultivated meat, some companies and researchers are using pluripotent lines. So these are things like embryonic stem cells or induced pluripotent stem cells, which are basically adult cells that have then been induced to go back into an embryonic-like state. And so when we say cells are pluripotent, that means they have the potential to become basically any cell type in the body. There are also multipotent cell types. So an example of this would be mesenchymal stem cells, which can become muscle or fat or bone or cartilage, but they can't become just any cell type in the body. And then we also have specialized or unipotent cell types. So something like a myosatellite cell, which is still in a proliferative stem cell-like state, but it's really fated to become one particular cell type once it gets a particular signal. It doesn't have multiple tracks that it might go down. When we talk about different cell lines, we can also refer to their proliferative capacity or how many times they can divide, as well as their stability or how predictable and stable is their behavior over generations. So if we think about an ideal cell line for cultivated meat, we want it to be able to divide many, many times so that we can get a large number of cells that we can then turn into meat. And we also want its behavior to be really stable. So if we differentiate it early in the process, it should behave the same way as if we let it divide 200 times and then differentiate it after that. And so we really see cell line development as something that's still a barrier in cultivated meat research. So for new researchers who are just getting into the field, this is a problem that everyone is having to solve over and over again. And so if you want to learn more about cell lines and our efforts to expand access, we have a webpage on our site, which is linked here. So the next area we can think about for cultivated meat is the culture medium, which is basically the feed that we're going to feed to the cells. And so we can divide this into two broad areas. One of those being the basal medium, which is just the nutrients that the cells need to grow. So this includes things like salts, sugars, amino acids, as well as growth factors, which are sort of a much smaller component of the culture media, but actually a huge contributor to the cost and also a huge contributor to the functionality of the media. And so these are signaling proteins that are going to do things like keep the cells in a proliferative state, keep them happy and healthy, and then different growth factors when we're at the point where we want the cells to differentiate will signal the cells to actually undergo that process. So if you want to learn more about cell culture media, this analysis from a couple years ago originally is a good starting point in terms of looking at the costs of cell culture media. Where do those costs come from and how could they be brought down? And so really what we need to do for cultivated meat is take something that at bench scale, we're talking about these $400 per liter formulas, which work great, but we're not going to go very far producing meat from something like that, and really getting it down to something more like less than $1 per liter. And we think that that's a tractable problem. It's a problem that multiple companies and multiple academic researchers are working on and making very good progress on, but it's certainly not a solved problem at this point. And so when we think about culture media for cultivated meat, we can think about kind of what's the spec sheet for what a good culture medium looks like. And so one requirement is serum-free. So you may have heard of fetal bovine serum, which is used a lot in academic research. And so what serum does is it basically provides primarily growth factors, but also some important nutrients, minerals, etc. And because it's providing so many things, many different cell types, grow really well under serum-based conditions, but we don't necessarily know what from the serum the cells actually like. And so that's the challenge for optimizing serum-free formulations, is to really figure out, okay, what are the needs of these cells and how do we meet them using an animal-free formulation. We also need formulas to be low cost and highly scalable if we're talking about large scale production. We need them to be high performance. So we need, high proliferation of the cells. We need continued genetic stability over time. And then we also need the formulation to be food grade. So we're talking about making a food product. We don't want to be introducing any safety issues. And we need the formulation to be compatible with the cell type that we're using and the species that we're using. So this may mean that different companies producing different products are going to need different formulations for their cell culture media. And so none of these are impossible things to solve for, but solving for all 5 of them at the same time and doing it well is a little bit of a challenge. I think it's a challenge that our industry is up for, but it's certainly by no means solved at this point. So the next area we can think about for cultivated meat is scaffolding. So basically what a scaffold is doing is it's mimicking the function of the extracellular matrix and the vasculature. So the extracellular matrix is this sort of protein-based matrix that makes up our sort of areas around our cells and provides a support structure for those cells. And then, of course, the vasculature, which are your blood vessels that carry oxygen, nutrients in, and waste out. And so with scaffolds, what we're trying to do is mimic a few different functions of those systems. So providing a structure that will allow for oxygen, nutrient, and waste transport. So if you think about sort of a clump of cells growing, the cells at the outside will have, really good access to the culture media, but those inside will have wastes building up from their various metabolic processes. They won't have nutrients coming in, and they will probably suffer from a lack of oxygen. And so that's going to cause those cells to die. That's not what we want. So we want to be able to provide a structure where there are channels or pores or something like that can get media very close to all the cells in your structure. We also want to provide a 3D structure as the cells are maturing. So cells are, really sensitive to the environment that they're growing in. They often really want to grab onto something. So giving them something to grab onto, and in particular, they're sensitive to the stiffness or softness of the substrate. So giving them something that matches, the stiffness of muscle or the stiffness of fat or the stiffness of bone is going to influence their differentiation. And so by tuning the stiffness and other cues provided in the scaffold, we can actually influence the properties of the final product. So think about like the marbling pattern of a piece of meat. Maybe we can influence that by tuning the stiffness of the scaffold. And then a final thing that a scaffold might do is contribute to the structure of the final product. So when you eat a piece of meat, you're not just eating cells, you're also eating the extracellular matrix, which is composed of collagen and other proteins. And that's really going to contribute to the texture and the experience of eating that meat product. And so with cultivated meat, we're going to have the same thing either from the scaffold itself providing that structure that will contribute to your perception of texture, or for some bioprocesses, maybe the scaffold will be designed to degrade over time and actually be replaced by extracellular matrix secreted by the cells. And so that will then give you that sort of textural experience. And so scaffolds can come in a couple of different forms. So the simplest is what we call microcarriers, which would typically be used during the proliferation phase. And these are basically tiny little beads of scaffolding material. So you can think of them as kind of the simplest scaffold. And what these allow you to do is grow cells in suspension culture that really want to be grabbing onto something. They want to be growing on something like a tissue culture dish, which is not super scalable for something like cultivated meat. So if we let them grow on these beads, they're a little bit more amenable to being grown in these large stirred tanks. And then particularly for the maturation phase, we're often talking about more complex scaffolds with a lot of structure to them. So those will, in some cases, be composed of the same materials as microcarriers, but in a very different structural form. So the final area we'll talk about with regard to the science of cultivated meat is bioreactor and bioprocess design. And so when we think about bioreactors used for cultivated meat, we can really divide them into two broad categories. So stirred tank bioreactors are basically what they sound like. They're large tanks where you put your cells in your media, and there's a mechanism for stirring them as the cells are growing. And so these have been pretty widely used in biopharmaceuticals and similar industries for quite a while. And so there's a lot that we can build off of in terms of optimization and scale up that's already been done. In contrast, perfusion bioreactors are at a little bit of an earlier stage. So these are a slightly more complex version of a bioreactor in which typically you would have, cells that are growing on a scaffold or something like that, and then you're actually pumping media through that scaffold. And so there are a few sort of variations on the idea of a perfusion bioreactor that people might be investigating for use in cultivated meat. But this is, sort of a really exciting area where not as much has been done in terms of optimization and scale up. And so there's a lot of room for growth in that area. So if you are interested in the science of cultivated meat and would like to learn more, I would recommend checking out the Science of Cultivated Meat page on our website. There's a lot of great information there to dig into if you're so inclined. And in the last few minutes, I'm just going to talk a little bit about sort of where we're at in terms of the trajectory of the cultivated meat industry and where we might see the next few years going. So this graphic is just illustrating the expansion of cultivated meat between 2015 and 2020, just to give you a sense of kind of where we're at in terms of the expansion of how many companies are in this space. So in 2015, we had 5 or so companies pursuing this area. And every year since then, we've seen a whole bunch more companies getting involved, recognizing the potential for this area. And we're now seeing a lot of diversity in terms of the companies that are pursuing this idea in terms of species, in terms of product types. So not only do we have, traditional meat, we also have dairy, caviar, foie gras, lots of, interesting different products that people are looking at making. And we're also seeing differentiation in terms of companies focusing on one particular area of the value chain. So maybe a company wants to get really good at cell culture media or really good at scaffolding. And so this just opens so many doors towards additional specialization and being able to get really good at one area. And it opens doors to partnerships between companies. And so finally, I just wanted to show this graphic, which is illustrating the history of cultivated meat up to this point and where we might expect to go, and trying to sort of put that into the context of a few different phases of production. So in the conceptualization phase, cultivated meat was a cool idea that people talked about. People have been, discussing the idea of cultivated meat for decades. But until about 2013 or so, it wasn't really the case that anyone had produced and tasted cultivated meat. So it was really just an idea. And so the lab proof of concept phase really kicked off with, most people would say, with the 2013 cultivated burger by Dr. Mark Post and his team. And so that's been followed up by a number of different, tastings by primarily by startup companies who have produced, these small, in some cases, very beautiful samples of cultivated meat. And so around 2019 or so, we start to transition into the pilot scale phase, where companies are actually moving into pilot plants and starting to produce products at a little bit of a larger scale, still fairly small. And so part of that was the first regulatory approval and the first commercial sale of a cultivated meat product, which happened last December of 2020, with Eat Just in Singapore. And so hopefully in the coming months and years, we'll see a lot more milestones like that one. But that's, a really key world first in the development of our industry is the first commercial sale. And so looking to the future, what we would imagine is, a couple scales beyond this. So pilot scale production is not going to do much about climate change or any of the other issues that we're concerned about here. But when we start to think about larger scale commercial production, we can think about companies moving into demonstration scale facilities and then finally full industrial scale production. And so we're at a really exciting point in the development of this industry. And I hope you're all as excited as I am to be part of the field over the next few years as we move into these larger scales. And so with that, thank you so much for listening, and I hope you enjoy the conference.
Hi there, and welcome to the Good Food Conference. My name is Ryan Dowdy, and I'm the Good Food Institute's Science and Technology Analysis Manager. Today, we'll be setting the stage for the Good Food Conference with Fermentation 101. With alternative proteins, we can make proteins directly from plants with fermentation technology or using animal cell culture. Fermentation is increasingly being used as an enabling technology for the alternative protein industry. It allows for the production of standalone protein sources or functional ingredients. Although fermentation is a relatively mature platform, alt protein applications still present new challenges, including selecting biomass for feedstock optimization, strain development and target selection, bioprocess design, and final production, formulation, and manufacturing. In the future, we won't see these three alternative protein production platforms as distinct industry segments, but rather as one large industry where we produce animal product alternatives across the spectrum, utilizing ingredients from one or more technologies. Products from microbial fermentation are likely to play a role along the entire alternative protein spectrum, making them a critical component of the industry. Examples include enzymes to improve functionality, ingredients to improve sensory characteristics, growth factors for cultivated meat, and 100% fermentation-derived ingredients to replace animal-based versions. Different fermentation approaches vary in the degree of downstream processing they require and in their functional activity in formulations. We classify these three approaches as traditional fermentation, precision fermentation, and biomass fermentation. Traditional fermentation uses intact live microorganisms to modulate and process plant-derived ingredients. This produces unique flavor and nutritional profiles and modifies the texture. Examples include fermenting soybeans into tempeh and using lactic acid bacteria to produce dairy. Biomass fermentation leverages the fast growth and high protein content of microorganisms to produce large protein quantities. Here, biomass serves as the predominant ingredient in the food product. Examples include corns and meaties filamentous fungi, used as a base for their meat analogs. Precision fermentation uses microbial hosts to produce specific functional ingredients that often require greater purity. This includes ingredients that can enable improved sensory characteristics and better functional attributes. Examples here include Perfect Day's dairy proteins, Clara Foods egg proteins, Impossible Foods heme, enzymes, flavoring agents, vitamins, pigments, and fats. 90% of modern cheese production uses fermentation-derived rennet enzymes rather than extracting it from calf stomachs. Similar to the plant-based sector's infrastructure needs, The fermentation space has a number of investment needs, including financing for dedicated and contract fermentation capacity at pilot, demo, and commercial scales. This enables new technologies to reach important development milestones. High demand from other sectors such as biofuels, pharmaceuticals, and nutraceuticals has put a premium on a lot of global fermentation capacity. One of the overarching challenges is that existing fermentation production and processing infrastructure, inputs, R&D tools, and workforce experience come from the high-margin life sciences industry, which has an emphasis on sterility that is over-engineered and overly expensive for food production purposes. For example, many bioreactors for pharmaceuticals are actually disposable, since single use is easier than sterilizing between batches. By contrast, food-grade fermentation needs to be multi-use, cleanable between batches, and does not have the same standards for sterility. While we have barely scratched the surface of what's possible, fermentation is poised for rapid growth. It's a mature technology that has been proven at scale. It's low cost and high volume. Fermentation is familiar to the food industry, and many food-safe microbes already have regulatory approval. R&D cycles are shorter for fermentation than for plants or animals. And finally, fermentation happens fast, with some processes taking only a few hours. The fermentation sector holds key opportunities for innovation. This includes target identification and selection, strain development, feedstock optimization, process design and manufacturing, and finally, formulation and product development. In terms of advancements in government regulation in the United States, multiple companies have already obtained no questions letters from the FDA for purified fermentation-derived ingredients, meaning the FDA does not object to the company's view that their ingredients are generally recognized as safe, or GRAS. Nature's Find, formerly Sustainable Bioproducts, filed a GRAS notice with the FDA in January 2020. The FDA's response is still pending. In March 2020, Perfect Day received a no questions letter from the FDA in response to their GRAS notice for beta-lactoglobulin, the major protein in whey. In November, the Singapore Food Agency updated a year-old guidance document on novel food safety assessments. The guidance provides little new detail as to which standards manufacturers must satisfy to obtain approval of their products. As it stands, the SFA strongly encourages companies interested in selling alt protein products in Singapore to contact the regulatory body early in the R&D and commercialization planning process. According to the SFA, the framework set forth in the guidance document steered the SFA's approval of Impossible's soy leg hemoglobin in August and Triton Algae's Chlamydomonas reinhardtii algae in November 2019. In December 2020, Impossible Foods received approval for their heme from the regulatory agency Food Standards Australia New Zealand. This approval became final in February 2021. For more information, check out GFI's The Science of Fermentation Explainer at gfi.org/science/the science of fermentation. Congratulations on attending this year's Good Food Conference, and thanks for listening to Fermentation 101.
Welcome, everyone. I'm Sharon Murray, GFI Senior Investor Engagement Specialist. So in this presentation, my colleague Marika and I will take you through everything you need to know to get up to speed on today's multi-billion-dollar alternative protein market. We'll take you through the state of the industry, investment trends, what's driving consumers, and of course, exciting white spaces that are ready to be filled, hopefully by some of you. A lot happened in 2020, including many firsts for the industry. We saw the world's first cultivated meat product to launch to market when Eat Just's Good Meat cultivated chicken bites were served in Singapore's 1880 restaurant. Perfect Day released its first animal-free dairy ice cream, That's under the brand Brave Robot, which if you have not tried, I highly recommend it. We saw former Israeli Prime Minister Benjamin Netanyahu become the first head of state to taste cultivated meat. And that was actually a tasting event that was organized by our very own GFI Israel in conjunction with Olive Farms. And then alternative protein dollar sales reached new heights and investments tripled. More on that last point in a little bit. Starting with alternative protein sales data, we've seen US retail sales of plant-based foods accelerating. They grew from under 5 billion in 2018 to 7 billion in 2020. That represents a 43% two-year growth rate. While this growth is exciting, it's even more impressive when compared to conventional protein sales. Over the last 2 years, dollar sales of plant-based meat, milk, and other dairy products grew at more than twice the rate of their animal-based counterparts. And plant-based egg sales grew at almost 10 times the rate of animal-based eggs. Turning to global sales data, we can see that global plant-based meat sales crossed that $4 billion mark in 2020, growing at a rate of 24% from the year prior. Western Europe and North America take the top 2 spots for largest markets for plant-based meat, although as you can see, North America has a much stronger growth rate at 40%. Plant-based meat markets in other regions are still relatively early in their development, so sales there are more so in the low hundreds of millions. Turning to plant-based milk, we can see that 2020 global sales were just shy of 17 billion. As that market is the most developed plant-based category, the annual growth has slowed down globally. On a regional basis, Asia Pacific is the largest market for plant-based milk at more than $9 billion in sales. That's likely not that surprising given the long history and popularity of soy milk in the region. The next largest market, North America, is actually only a third of the size of Asia Pacific, but it is one of the fastest growing markets for plant-based milks. We at GFI expect this industry to continue to grow in the coming years, but you don't have to just take our word for it. On this slide, we've summarized a range of forecasts published by consultants and banks. And as you'll be able to see, expectations for global alternative meat market are around 100 billion by 2030. And if we want to look across all proteins, there's a recent report that we cite actually in the title, released by Boston Consulting Group, or BCG, and Blue Horizon. And they forecast a base case of a $290 billion market in global sales across all types of alternative proteins by 2035. So taken together, I think we can safely conclude this is not a fad, but a long-term shift in protein consumption. Okay, moving on to my favorite, given my role, investment and industry trends. This first chart illustrates how investments have truly skyrocketed. Last year, we saw venture capital and private equity investments reach 3.1 billion, which is 3 times more than the prior year. And in the first half of this year, we're already on track to meet or beat that pace of growth. Zooming in to plant-based investments, we had 2.1 billion invested here last year, and that represents nearly half of the total investments that had been made over that prior decade. This year, plant-based startups continue to surpass the other 2 segments in their capital raise, but that lead has significantly narrowed. And I suspect that's likely due both to the maturation of the fermentation and cultivated meat industry segments. And on a related note, investors' increased interest and familiarity with such companies. But it also might be due to some mature plant-based companies going through exits rather than raising large private rounds, and I'll touch upon that more a little later. So what has all this investment gotten us? Well, there are now over 1,200 plant-based companies in GFI's company database, and many of them were founded just in the last 2 years. We also see many large and established food companies involved in alternative proteins through investments, or product lines, or both. In fact, every single one of the top 6 meat companies in the US has an alternative protein product line or has invested in alternative protein. Similarly, fermentation has seen incredible gains in investments, particularly over the last 2 years. And that pace of growth appears to be accelerating. So fermentation startups have already raised 72% of last year's investment figure in just the first 6 months of this year. Matching that timeline of investment flows, over half of fermentation companies dedicated to alternative proteins were founded in 2019 or later. And the majority of these companies are focused on precision fermentation and biomass fermentation, while traditional fermentation makes up a smaller proportion of companies. And finally, cultivated meat companies are rapidly approaching that $1 billion mark in total investments. Investments here really took off last year as investors saw proof of concept and gained confidence that cultivated meat is a critical solution to meeting the world's growing demand for meat. That is to say, very far from science fiction, which was a fear of investors in the early days. And this year, I'm actually thrilled to share that we've already surpassed last year's investment total. This segment has expanded rapidly. So in 2016, we had just 4 companies, and now there are at least 70 around the globe. In addition, there are 40 established companies that have publicly announced a business line in cultivated meat. But don't worry, there is still ample space for established companies and startups alike to enter this ecosystem. Those of you who are discerning may have noticed on my cultivated meat slide that Blue Nalu raised the 2nd largest cultivated meat round this year. And that's really exciting and significant because alternative seafood is still very much an emerging category and a major white space, as you'll hear from Marika later in this presentation. Like for cultivated meat, investments in alternative seafood this year have already surpassed last year's investments. And finally, at least for me, let's take a look at liquidity events or exits. So the vast majority of these have taken place in plant-based foods, which is the most established category, and most of those have been in the form of M&A, merger and acquisition activity. The largest disclosed deal to date is Danone's acquisition of White Wave Foods for $12.5 billion in 2017. And White Wave Foods, for those of you not familiar, was the operator of the Silk brand and other plant-based brands. This year, we've seen a number of notable events, including plant-based milk company Oatly's IPO on the NASDAQ. I suspect many of you have heard of that. That was at an implied valuation of $10 billion. Then we also had JBS acquire Vivera, which is Europe's 3rd largest plant-based food company, for approximately $450 million. And that last one actually provides further evidence that major meat companies recognize that the consumer shift into alternative proteins is a high growth trend that they do not want to miss. And now I'm pleased to turn it over to Marika.
Hi, everyone, and thanks so much, Sharon. My name is Marika Azoff, and I am GFI's Corporate Engagement Specialist, and I focus on our Sustainable Seafood Initiative. So now that we've gotten an overview of the state of the alternative protein industry and investment trends, I'm going to talk to you a little bit about what consumers want, and then followed by product categories and white spaces within the alternative protein industry. So in addition to the increasing retail sales and increasing investments that Sharon shared with us, consumer trial of plant-based foods also increased in 2020, which we can see here on this graph. So this study done in the US by UBS Evidence Lab found that the percent of consumers who have tried plant-based meat increased nearly 4 times from 13% in Q3 of 2019 to 48% in Q3 of 2020. This is massive growth in trial over just the course of 1 year. And in a separate study done by Matson, they found that 60% of consumers believe that plant-based eating is a fundamental change in how people consume food and will continue to be so for a long time. So again, and this is not a trend, what was once a niche category has now become mainstream, and many consumers expect that plant-based foods will have a lasting effect on dietary habits. So what's driving this shift? Mintel's 2020 US plant-based proteins report shows that consumers indicate that health is the primary reason they try or eat plant-based foods, and taste, environmental concerns, and animal welfare concerns are secondary. And this finding is consistent across a wide number of studies from 2018 to 2020. And while health is a top motivator for bringing consumers into the plant-based food category, taste and price are also key factors influencing trial and continued consumption. So perceived taste is among the top reasons consumers either don't eat or won't try plant-based foods. So therefore, we know a lot more work and R&D needs to go into getting these products to taste like their conventional counterparts. We also know that the average prices for plant-based products are still 1.5 to 2 times as high as their conventional counterparts. So continuing to reduce price is an important step towards widespread adoption of plant-based meat. And several plant-based meat companies moved closer to price parity with animal-based meat products in 2020, including Impossible Foods and Beyond Meat, which have recently reduced their prices. So given that cultivated meat is only available for sale in parts of Singapore, we really don't have as much data on consumer attitudes towards it yet. However, this 2021 study indicates that around 70% of UK and US consumers are at least somewhat willing to buy cultivated meat, and 49% in the US and 70% in the UK are at least somewhat likely to pay more for it. So in this last section, I'm going to dive a bit into the alternative protein product categories, as well as some white spaces in the industry. So as Sharon mentioned, the plant-based food industry in the US is worth $7 billion. And in this table, we can see that most plant-based categories experienced double-digit growth from 2019 to 2020. And in the US, plant-based milk has the largest share of the plant-based market at 15%. And it doesn't only have the greatest share of the plant-based market, it also has the highest household penetration rate at 39%. And while I'd love to dive into each of the categories on the previous slide, for the sake of time, I'll be focusing on plant-based meat for the remainder of the presentation. However, I really encourage you all to visit our website at gfi.org for a full breakdown of each category. In 2020, plant-based meat retail sales grew by 45% to $1.4 billion in the US. And we also saw that of the US households who purchased plant-based meat, 63.1% were repeat purchasers. These numbers are promising and show massive growth. However, plant-based meat currently represents only 1.4% of dollar sales for all meat sold in retail in the US. And comparatively, plant-based milk represents 15% of the dollar sales for all milk sold in retail in the US. So we like to frame things in terms of opportunity, and this certainly is an opportunity. So in order for plant-based meat to reach market share parity with plant-based milk, we're really looking at a $14 billion opportunity. And we can break plant-based meat down into these subcategories, and this slide shows the most popular plant-based meat formats and types. And in the next 2 slides, I'm going to discuss the white space opportunities in both plant-based meat subcategories and formats. So GFI's Advancing Solutions for Alternative Proteins database is chock full of opportunities in the alternative protein space. And if you haven't already, I really urge you to take a look at it and sift through all of the incredible opportunities that we've compiled there for you. This slide contains several of the plant-based product white spaces. And while I don't have time to go into each one, in the next slide, I'm going to highlight alternative seafood. In the US in 2020, plant-based seafood retail sales grew by 23% from 10 million in 2019 to 12 million in 2020. And while this early growth is super promising, alternative seafood still remains a market white space and many steps behind terrestrial meat and other plant-based alternatives. So if you remember, in a couple slides ago, we compared plant-based meat market share to the plant-based milk market shares in the US, and we can do the same thing with plant-based seafood. So plant-based seafood makes up only 0.1% of the retail dollar share amount of all seafood products sold in retail in the US. So if plant-based seafood were to reach market share parity with plant-based meat, we're looking at a $221 million opportunity. And we can take it one step further and compare plant-based seafood to plant-based milk shares. And then we're looking at a $2.5 billion opportunity. And keep in mind that this is only reflective of retail sales in the US. And because the majority of seafood sales in the US occur in food service, this opportunity is an underestimate of the total market opportunity, which is most likely more than double this estimate. I really encourage you all to visit our Sustainable Seafood Initiative webpage at GFI/seafood to learn more about opportunities in alternative seafood. I want to conclude our presentation by taking a step back and looking at how the relationship that many humans have to meat has changed over time. And with the growth of alternative proteins, how it will only continue to change. So technological advances such as centralized farming, which I know now doesn't seem like a technological advance, but it once was, and food tech innovations such as cold shipping have really abstracted the concept of meat away from the animal. So much so that the definition of meat is shifting to focus less on the specific animal and more on the functional and experiential purposes of meat. Alternative meat, egg, and dairy companies are breaking meat, eggs, and dairy down into their component parts and recreating each component using a plant source and/or animal cells. So in effect, alternative protein companies are revolutionizing the idea of what meat, eggs, and dairy are. And that's even made clear in the terminology we use, right? Cultivated meat or plant-based milk. And as the alternative protein industry continues to grow and technological advances continue to enable companies to produce meat in different ways, we are getting closer and closer to GFI's goal, which is building a world in which alternative proteins are no longer alternative. We really hope you enjoyed this session and enjoy the rest of your conference experience. Please visit our website for more detailed market information and make sure you sign up for our newsletter at gfi.org/insider to stay up to date on the latest news. Thank you so much.